Welcome friends, once again in this spoken tutorial on transformer part 5. In this we will discuss the efficiency and regulation of the transformer. The efficiency of a transformer is defined as the ratio of input power to the output power. So efficiency is equal to the ratio of output power divided by input power. We can write input power as output power plus losses, that is output power plus core loss Wi plus copper loss Wc. At a loading factor of x, the output is given by apparent power into power factor into loading factor. So it's x into kV into 1000 into power factor, where x is the loading factor and Pf is the load power factor. The core loss in the transformer is constant because the applied voltage is constant, and copper loss depends upon current. If we consider Wc as copper loss on full load, then copper loss at loading factor x will be x square into Wc, and therefore the output will be x into kVA into 1000 into power factor, and the efficiency will be given by the formula x into kVA into 1000 into power factor, that is output divided by output plus core loss plus the copper loss, which is x square into Wc. The percentage efficiency can be calculated by multiplying it above formula by 100. A good transformer has generally the efficiency more than 95%. The efficiency of a transformer increases with increase in load. At no load, of course, it is zero. It increases as the load increases, and at a particular load it becomes maximum, and then it starts decreasing. The maxima of this curve between the load current and the efficiency can be found out, and we get the condition for maximum efficiency as the constant loss is equal to variable loss. Constant loss is core loss, well, variable loss is copper loss, and therefore condition for maximum efficiency is core loss is equal to copper loss. Core loss is Wi, and copper loss at any loading factor x is x square Wc, and therefore condition becomes Wi is equal to x square Wc. And from this, the load kV at maximum efficiency can be found out as x is equal to root of Wi upon Wc. So this formula gives the loading factor at maximum efficiency. Now let's discuss the regulation. What is meant by regulation? The transformer winding has resistance and leakage reactance. When the transformer is loaded, current flows through this resistance and reactances. As the load current increases, this drop in the resistance and reactance also increases. This results in decrease in secondary terminal voltage. This drop depends upon amount of current and the value of winding resistances and leakage reactances. So the regulation of the transformer is defined as a drop in secondary terminal voltage from no load to full load, expressed as percentage of no load voltage for regulation up and percentage of full load voltage for regulation down, keeping the primary voltage constant. Thus the formula for regulation up is percentage regulation is equal to VNL, no load voltage, minus VFL divided by VNL into 100. Regulation down is given by VNL minus VFL divided by VFL into 100. Generally, the regulation up is considered for a transformer, and for a good transformer, regulation must be less than 5%. Regulation formula can be expressed in terms of parameters of the transformer winding, that is winding resistance and leakage reactance. The drop VNL minus VFL can be expressed as I1 into R01 cos phi plus or minus X01 sin phi, or I2 into R02 cos phi plus or minus X0 into sin phi, where R01 and R02 are the equivalent resistances referred to primary and secondary side respectively, whereas X01 and X02 are the equivalent reactances rather, leakage reactances referred to primary and secondary side respectively. Thus, expressing drop in this way, we can write the formula for regulation as drop divided by V1 or drop divided by V1 dash, that is I1 R01 cos phi plus or minus X01 sin phi divided by primary applied voltage V1. Refer to secondary side, we can write I2 X02 cos phi plus or minus X02 sin phi divided by V1 dash. Remember that V1 dash is the primary voltage referred to secondary side. Thank you.